I think we're going to get started now. Thanks, everyone. As a reminder, as you join, why don't you just drop us a quick note, let us know where you're joining from on the planet. Looks like we've got people joining from the four corners of the globe, so this is incredibly exciting. I am Omkar Arasaratnam. I'm the general manager for the OpenSSF, and I'm going to be your host and moderator today. We've got a great talk lined up for you. We're going to talk about salsa. I don't mean chips and I don't mean picante, but I do have some incredible material coming up for you. So, Jennifer, if we can advance to the next slide. While we wait for everyone to join, as mentioned previously, please be mindful of the following. One, add questions using the Zoom Q&A feature. We will get to them at the end. Please follow us on X, formerly known as Twitter, at OpenSSF, on Mastodon, as well as LinkedIn at the links below, and visit our website, openssf.org, and sign up for training, openssf.org/training/courses. This Tech Talk is being recorded. With that said, we can move to the next slide, which is our antitrust policy notice. So the Linux Foundation meetings involve participation by industry competitors. It's the intention of the foundation to conduct all of our activities in accordance with applicable antitrust and competition laws. It is therefore extremely important that attendees adhere to the agenda and be aware of and not participate in any activities that are prohibited under applicable U.S., state, federal, or foreign antitrust and competition laws. Examples of these types of actions that are prohibited can be found at the URL below. Feel free to contact the contacts that you see on this page should you have any questions. And I think we can move on to our next slide, which is the code of conduct. The Linux Foundation and its project communities are dedicated to providing a harassment-free experience for all participants at all of our events, be they held in person, as per our event that we just got back from in Bilbao, or virtually, as the event that you're attending today. All event participants, whether they are attending in person or a virtual event, are expected to behave in accordance with professional standards, with both the code of conduct as well as their respective employers' policies governing appropriate workplace behavior and applicable laws. Code of conduct can be found below. Housekeeping, as mentioned earlier, please submit your questions during the meeting by using the Q&A feature on Zoom. We're going to get to them at the end. We look forward. I already see a bunch of them streaming in. We're going to have a great session today. Thank you. With that said, let's meet our panelists. So moving first to Mr. Lieberman. Michael, do you want to provide a brief introduction?
Sure. I'm Michael Lieberman. I'm a co-founder of a software supply chain security startup called Kusari. I'm a member of the SLSA steering committee, as well as a member of the OpenSSF Technical Advisory Council. And I'll hand it now over to Marcella.
Yeah. Hi, good morning or good evening, good afternoon, wherever you are. I'm Marcella Millara. I'm a research scientist at Intel. I am a frequent contributor to the SLSA specification. I'm a core maintainer for the Intuitive attestation framework and a few other sub-projects. That's just a little bit of my sort of open source background in this space. Next up is Lorelei.
Thanks, Marcella. I'm Lorelei Catapan. I lead the product team at ActiveState in the software supply chain arena. My focus really is helping security leaders, developers, in addressing their challenges in the software supply chain security. And next is Joshua.
Hi, my name is Joshua Luck. I'm a software engineer working at Verizon in the Open Source Program Office, and I am engaged and actively contributing to a bunch of open source software efforts around software supply chain security. That's it for the intro. So over to you, Omkar.
Thanks, Joshua. I am humbled to be in the presence of folks of this caliber. I think it's going to be an amazing session that we have today. So to kick things off, we're going to talk about what salsa is, and we're going to go back to Michael. Michael, take it away.
Sure. So this is the salsa logo. Can you go to the next slide? So before we talk about, what SLSA exactly is and why we believe it to be solving some of the problems in the software supply chain space, let's really focus on what is the problem first, right? So software supply chain security is really about securing the ingestion and production of software, right? And so that means securing your SDLC, right? Securing your software development lifecycle. And so, the problems that the framework SLSA is trying to solve, and for folks who aren't aware, SLSA stands for supply chain levels of software artifacts, and the breadth of the problem here is you have a developer writes some code, goes to a source repository, it gets built, you pull in dependencies from the outside world, you build everything up, you package it up together, you publish that package, whether it's publicly or internally, and then some level of consumer, whether it is an external customer, whether it's internal customers to your organization, they consume that software. And there's lots of things that can go wrong, right? A developer can submit, an unauthorized change, right? Or maybe you have an unauthorized developer, right? Who somehow has access into your systems and is writing code. Your source repository might get compromised. Somebody might push, things into the source repository without authorization, without access. Your build might pull from the wrong location, right? Your build might pull from from the wrong source repository. You might be pulling in dependencies that are incorrect. You might just be building incorrectly. Like think of the SolarWinds attack, where a DLL was swapped out in the middle of the build process, right? And then when all of that's done, the pack when a package is published, you might have somebody publishing a package that is what didn't actually go through all of your security processes, wasn't part of your normal SDLC. Somebody got access to your package repository and published something. And then as a consumer, you want to know, like, well, hey, am I actually pulling software from the vendor I expect? Am I pulling it from the open source provider I expect? Am I pulling it from NPM, like the public NPM repository? Am I pulling it from Maven Central, or am I pulling it from some malicious provider? And sorry, next slide. Oh, whoops, back one more. So SLSA is trying to solve the whole sort of end-to-end picture there from the production side. But right now for SLSA 1.0, we are very much focused on the build track. And so the build track here is really sort of those arrows that are going into the build and the arrows that are coming out of the build. So in this case, we're looking at, the build system pulling down source and dependencies, as well as the build then, once it's done, building an artifact, building a package, building a container, whatever that may be, and then publishing it, right? And so SLSA 1.0 is really, really focused on, and SLSA in general is really focused on provenance. And so at a high level, that means we are doing things like recording where stuff is coming from. So SLSA 1.0 is focused on recording the source, the build ingests. So the build system itself, where did it pull code from? And then the build system, where did it pull dependencies from? What were the parameters to the build? And then at the end, also, what did the build actually generate, right? So what is the hash of what it actually generated? And then tracking all of that sort of information so that you can then have it in the future so that you can use it for, analysis and security purposes. Next slide. So now let's look also a little bit of where SLSA comes from, what the sort of depth of the problem is, and why SLSA fits into the solution. So as I stated before, right, the problem really is about where did my software come from? And so you need to have a couple of different things. One is you need to have a foundation for your trust. So you need to know who do you trust to produce your software, right? Is this build coming from Google? Is it coming from GitHub? Is it coming from Microsoft? Is it coming from, malicious provider X? Is it coming from just a random person? How do you know? Well, you need to know whose identities do I trust? Where are these things coming from? Then you need to have a set of like claims being made about the software. So in this case with SLSA, right, you need to say, well, SLSA is claiming that I pulled the software from this location. I pulled the source code from this location. I pulled dependencies from this location and pulled it all together. And then I am signing it with some identity, so associating with the provider of that software. And then in the future, for when you want to go back and say, well, was that information correct? Is there something that I should be worried about? You need to have some sort of analysis of those pieces. So that's stuff like walk and similar things like that. And then finally, that allows you to then make policy decisions about what software you actually consume and end up running. Like, did this software have valid SLSA attestations coming from the right parties at the right time, so on and so forth. Next slide. So, yeah. And so at a level down, SLSA is a supply chain security framework. So SLSA 1.0 has 3 levels. It's focused very much on the producer of software, not so much on you as the consumer, though you as the consumer should be able to say, hey, because people are producing software with SLSA and I trust that process, I'm comfortable with ingesting that. SLSA right now is also focused, it's split into a couple of different tracks. The first one right now is the build track, but very soon you'll be seeing stuff like a source track and some other ones. And SLSA is the provenance that I had stated before in the problem space, is in Toto attestation format, which is an easy to generate and consume sort of JSON format that is also has a signature format called Dizzy. Next slide. And why we've been focusing on the build track right now is, hey, there's a lot to supply chain security. The build is critical to the foundation of supply chain security, right? Because if the build is compromised, pretty much everything else is lost, right? So that's why we've put such a focus for 1.0 right now. And then also generally, provenance has been a big missing piece of the picture, right? How do we solve, one of the big open questions here is how do we track from source to build artifact, right? Because if you have that information, you could always go back. You could always go back and better understand how a piece of software was built and that sort of thing. Next slide. And now just at a very high level, what SLSA isn't, right? So SLSA for the 1.0 build track, right? It can't prevent malware from being built. It just makes it easier to detect, right? You could go back and say, wait a second, the build said it built this hash, this commit hash, but that commit hash doesn't seem to be something that we actually signed off on. Something must be wrong with our build. It could help answer those sorts of questions. And then also SLSA is not a comprehensive set of rules for ingestion, right? It's very much focused on the cutting edge of software production. And so if you're looking for some of that, there is an OpenSSF companion project called Secure Supply Chain Consumption Framework, S2C2F, which is focused on, for folks who don't have SLSA across the board, what are the things you can do to better understand that? And now I'm going to hand it over to Marcella.
Thanks, Mike. Yeah, so given this background that Mike has given us, right, I'm here to dive deeper a little bit into the concepts of trustworthiness and transparency and how they relate to SLSA and what they give us. So next slide, please. I'm flashing this slide back up, right? Because as Mike said, there are a number of possible attack points in the supply chain. And so I always like to go back to this when I'm talking about trust and what it means to establish and gain trust in software. Next slide, please. So if you truly want to answer this question of trust, right, Mike was talking about the various layers of the problem space, but it's not a simple question at all, right? We're asking a whole host of questions, right, around the who, when, how, what, and everything that was involved in the making of a piece of software. Next. So again, looking back, right, SLSA fits into the layer of software attestations, and these really help us answer the how and the what parts of the trust question, right? Next slide, please. So software attestation and transparency, what do they really give us, right? They give us three kind of key things. And this is sort of general across the software supply chain, but hopefully you'll see soon how this relates to SLSA. Software attestations and transparency are here to capture information about any aspect of the software supply chain, right? They then also enable the verification of properties of software artifacts in their builds. And ultimately, the goal is to reduce the risk of security problems going undetected. So it's kind of a trust but verify trust model where you hope that everyone's doing the right thing, and at the same time, you still want to make sure that security problems didn't sneak in. Next slide, please. So to illustrate what a transparent supply chain that provides SLSA build provenance looks like, consider a typical supply chain, right? Next slide. Instead of, next slide, please. Thank you. That's good. No, back up, sorry. Thank you. Instead of just generating the package, right, at the end of the build phase, a supply chain that implements SLSA will also generate a piece of provenance. This is what Mike was talking about before, which is really just a metadata object or file that accompanies the output of the build process. Next slide, please. So on the consumer's end, they can then use the SLSA metadata to verify the trustworthiness of a package based on this provenance metadata. And as Joshua will actually show later in a demo, this is the consumer's tooling really doing all the work, right? It's not the consumer themselves manually verifying SLSA provenance. So it's all, again, meant to be automated. Next slide, please. And finally, before I hand off to Lorelei, I do want to cover the sort of guiding principles that have their foundation in this trust and transparency in these concepts, right? So the first is trust a small number of platforms, focus on artifacts. And the main reasoning here is that hardening and verifying platforms, that's your CI/CD systems, your infrastructure, and all of those pieces, is actually very difficult and expensive and often requires some manual work. And so, and in addition to that, right, like each trusted platform expands the attack surface of the supply chain. So by focusing on artifacts, what we really gain is, and we're verifying how artifacts are produced, right? What we gain here is that this is easier to automate, easier to scale out by having a small number of platforms that we trust to trust and still verify to do the right thing. Next slide, please. So the second guiding principle follows from the first, right? If we're focusing on artifacts, then we want to be able to trace software back to its source, not to individuals, right? The key idea here being that code is static and can be analyzed each time it's produced. People, on the other hand, right, we are prone to making mistakes, having our credentials compromised, and not every person is a good person, right? So here the main point is really to reduce the risk of undetected tampering by trusted people, trusted credentials. Next slide, please. And finally, this comes back to this notion of attestation, right? SLSA absolutely prefers attestations over inferences. The idea here is not to infer security properties from a platform's configuration or a build configuration, but to, again, verify, trust but verify across the whole supply chain. So we create an explicit verifiable record that hopefully proves that the trustworthy platforms we're relying on have actually, again, built a software artifact correctly, and also without any sort of intermediate actors potentially needing to be trusted. So with that, I'm going to hand it over to Lorelei now, who's going to keep going. Thank you.
Thanks, Marcella. All right, so Michael talked about, introduced, what SLSA is, and then Marcella drilling into the transparency and trustworthiness of software. What I'm going to be talking about is now the security levels of SLSA. As Michael had I mentioned, they're organized into levels, and these levels, help guide you to basically understand and determine the confidence of your software. So, for example, you don't want your software to be tampered with, so you want to know when it's tampered with, and how can you securely trace it back to the source. So actually, next slide. So in terms of the SLSA levels, they're organized again such that the higher the level of SLSA, the higher it guarantees the security of your supply chain. And as Michael has mentioned earlier, the SLSA levels are split into tracks. So for this section, I'll primarily be focused on the build track. And there are essentially two main actors in SLSA, right? There's the producer, in this context, the software producer, and then there's also the build platform. So next slide. Okay, so let's talk about the producer. So as a software producer, what are the requirements on your end, right? So you'll want to be able to choose an appropriate build platform. You'll want to follow a consistent build process, and you'll want to be able to distribute provenance along with the software that you're producing, kind of like what Marcella was talking about, providing the provenance as you are producing those artifacts of your software. And when you're choosing a build platform, for example, you'll want to make sure that it's secure, right? And as far as a consistent build process, you want one that's based on a well-defined process that can easily be tracked, as opposed to, for example, where you may have tons and tons of ways to produce the same build output. And as far as the for the provenance information, whether you're publishing it to a central repository, such as an OCI registry, or emailing it to your consumer, although we don't suggest that you email it or recommend it. You want one that's not confusing, one that's easily digestible for your consumer. And there's some examples here in the bottom of the slide. You've got Kubernetes, which can use SLSA to generate the SLSA provenance. You've got NPM packages recently. They've been generating SLSA provenance as well. And you can imagine, an application like a Hello World application that can produce SLSA provenance. Next slide. Okay, then there's the build platform, as I mentioned. There are generally two main categories of requirements here, as you see on the slide. And the first category is the provenance generation. So it's basically like recording the input, such as the source that goes into your builds and the dependencies that go into your builds, right? The input of your build. You record the steps of what's happening in your build, and of course, the output of that build. So you're recording those artifacts per se. Then the second category here is around the isolation of your builds. An example here is you'll want to make sure that, no given build can mess with another build, right? And that's regardless of whether they're running at the same time or in sequence. And some examples here in the bottom are some of the build systems that can be used. There's Tekton, GitHub Actions, GitLab CI, Jenkins, and so on. And next slide. Now I want to kind of dive into the provenance generation here. What exactly do we mean by provenance generation? And here there are 3 requirements for that element, right? There's the exists, authentic, and unforgeable. So on the exist side, for this is primarily for SLSA level 1. It's like you're generating that SLSA provenance, and as Mike had mentioned, you're using the in-toto format. You could be using the in-toto format, which specifies the statement, and that statement includes the subject and the predicate. It could also be as simple as recording the logs, for example, of your builds. And all of this would be very useful when you're auditing, for example, or when you need to do some investigations. So you want those information in order to be able to successfully do that. And it's especially when you're tracking down, for example, an artifact or a specific artifact that made it into your build system. You'll want to know, as Marcella mentioned, who and what built it, how was it built, where it came from, and so forth. Then for the level 2, you'll want authenticity. And this is when you're actually citing the provenance. This is when you're associating a build with a software producer, one that produced the artifacts and so forth. And then for level 3, getting into the unforgeable, this means that the build system will generate the provenance and not the user-defined build. And that's an important concept to grasp. So for example, this means that the signing secrets that you're using can't be accessible by the build itself. And there are ways to achieve this, like using ephemeral signing secret or per build signing secret. And what this does is it helps you protect the provenance from, for example, malicious user builds. Next slide. All right, now diving into the isolation or isolation strength. And here there are 2 main requirements, as you see here, hosted and isolated. Then the first, for the hosted, it means that you'll want to use a hosted system. So you're not, for example, randomly running your build on random local workstations or a developer's desktop or a laptop and so on. And then the second is the isolated piece. And what that means is that the builds can't affect each other, right? Concurrent builds can't basically cross-pollinate or access each other's resources. And the build environments are ephemeral. Okay, next slide. Okay, so wrapping this all together here, basically this is a summary of the security levels of SLSA. So for SLSA level 1, essentially something is better than nothing, right? Again, it helps with investigation, it helps with auditing, but it's only as good as the trustworthiness of where it came from, right? The big piece here is really, it's a start. And most folks today are not really recording what they're building, how they're building it, what they're producing, and so forth. So this is a really good start for everyone. And then there's this also level 2. Now you're associating the identities, right? The identities and the systems with the software itself. This prevents it prevents attacks, for example, against the developers and their workstations. And because you've associated the identities with the build systems, you now have a better understanding of how and where the software was built and who built it. And then the last level is also level 3 for now, is now you're enforcing the security at the individual build levels, right? And this helps prevent attacks against the build system itself. And by enforcing that isolation and that unforgeable of the builds, you can prevent, or it helps to prevent the malicious builds from being able to infect other builds in the system. So what this means is that, like, for example, compromise of a single build won't necessarily mean that all of the builds in the same system are actually compromised. You'll also have the ability to have more granular identities that can be tied back to an individual build or build step. So, for example, you know that the software was built by a specific provider with a specific build steps at a certain point in time. And with that, we'll move on to Joshua to actually, how do you implement it?
Cool, thanks, Lorelei. So, yeah, I'm going to talk a little bit about implementing SLSA, both in build platforms and as users of, well, GitHub specifically. We've got a nice little demo that I hope will tie all of the knowledge that the rest of the panel have shared together. So, who implements SLSA? If we refer back to the principles that Marcella shared earlier, you know, we said that the first one is to trust platforms and verify artifacts. And SLSA is designed to be implemented by platforms and ecosystems, those that constitute our software supply chains and produce the artifacts that are distributed with their associated provenance. So as producers of software, we can then choose platforms which implement SLSA, and we can opt into any of the features that they enable, you know, in any configuration we have to opt into to enable these features, and that will be as easy. It's as simple as that, really, for users to generate SLSA provenance. The fundamental first step is that users have to decide to trust these build platforms. Have they implemented SLSA correctly? And so for that, we are providing guidance for kind of technical documents, almost like high-level design documents that build platforms can produce that indicate how they have gone about meeting the SLSA requirements, to make it a little bit less abstract, to make it easier for users to make that trust decision. And once you've chosen your build platform and you've got this confidence in it, then you know, you can start producing SLSA provenance. So, sorry, next slide, please. And the next slide again, sorry. So this is what I was just talking about. And of course, generated provenance is only useful if someone is inspecting and verifying it. That's the kind of the policy piece that Mike talked about earlier. So a consumer of an artifact has to verify that the artifact and its provenance metadata meet their expectations. So the first thing they have to do is choose their trusted build platform and add this builder identity to the tool's root of trust, hopefully only after reviewing the builder evaluation. And then the tool will perform verification steps, which is verifying the signature on the provenance envelope, ensuring the subject of the provenance attestation matches the artifact, and then verifying various fields of the provenance attestation meet their expectations, including whether the builder ID is the expected builder, and whether the source code came from the expected source code repository. And forming these expectations sounds onerous, and for individual users, certainly that would be true. But as the rest of the discussion has intimated, there are architectures being deployed today and others that we are exploring in the SLSA project for how to do this expectation forming and policy generation. In abstract, we don't anticipate that users will be explicitly verifying, you know, artifacts and the source code repositories they come from and things. There's a bunch of possible architectures, including maybe like at the simplest, we could do trust on first use and detect drift, and that would still provide massive benefit. Like if a publishing endpoint, a package in a registry is suddenly publishing from a different source code repository, that would be useful information to know, and that would still provide an increased measure of protection against tampering. Okay, so next slide, please. Let's try and make this more concrete. Let's look at a demo. I'm going to demonstrate using the SLSA GitHub generator, which is really neat project in the OpenSSF as well. It uses a mixture of GitHub features and the SIG-Store project to implement SLSA requirements. So GitHub reusable workflows provide the isolation strength of isolated. So if we refer back to what Lorelei was saying, this is level 3 isolation. And then a combination of GitHub's workflow identities and the SIG-Store project enable us to generate unforgettable provenance. So that's level 3 provenance generation as well. There's some great details available for how this project works, but let's see it in action. So if you could go to the next slide and play the demo, please.
Using the SLSA GitHub generator to implement the SLSA requirements for a project on GitHub. Now, SLSA GitHub generator is a project, an OpenSSF project that is mostly implemented by folks working in the Ghost team at Google, and it's really easy to adopt. We just have to tell in our workflow, we have to state that we want to use this reusable workflow from the SLSA GitHub generator project, or indeed, there are multiple workflows to choose from. In this instance, I am building a Go project, so I am using the SLSA build level 3 builder for Go. And then I have a sibling configuration file that tells one of the components in the builder how to build my Go project. And we can then pop over to GitHub and run the workflow. I'm just going to run it for my main branch. Usually you would have the release workflow triggered automatically when you tag a release or whatever your process is. And you can see, like most CI/CD development, I've got a bunch of failures as I figured out how to integrate this. But now the build's going, and you can see that I have 2 top-level jobs for the 2 binaries I want my project to produce. And each of these is triggering a bunch of other jobs that are all part of the reusable workflow from the generator. So the first thing it does is it builds a Go tool, the builder tool. That's what reads the configuration file and actually builds my Go project. So only things that I've defined in my source code repository can influence the build. And one of the really nice features about the generator is that it leverages the reusable workflows feature of GitHub, means that all of the different jobs are run in isolated virtual machines. And so each of the steps can't tamper with the other. And there's a communication pipeline where the workflows can pass outputs between each other. And so we can send information between the jobs, between the different virtual machines, and the generators use that to do things like pass a digest of a file that they've generated between jobs, so that when the next VM picks up that file from storage, it can make sure that the file hasn't been tampered with. But yeah, this is all running in separate virtual machines, so we're getting that isolation requirement of the SLSA project at build level 3. Now you can see that it's busy building my project. This is in an isolated VM using the builder that we generated earlier, reading from my configuration file. And then once it's finished the build, the values for the provenance will be written in a separate VM so that they can't be tampered with by the build process. So my provenance generation happens again in a separate isolated space. Should be finished any moment now. Should only take a few minutes. And then we'll have all of our assets uploaded, and we can fetch those and inspect them and see how things look. So here we go. We've got these are the builder binaries that the project generated, so we can make sure they match our expectations. You know, we can build them locally and verify that the version built on GitHub is the same as what we would have built ourselves. And we can download our two files here. I'm just going to download one of the binaries and its associated attestation, provenance attestation. I'm going to inflate. They are compressed archives, so I'm just going to inflate those. Doing super well at driving the command line here. There we go. Let's take a look then at our attestation. So here we go. We've got, we're using an older version of the provenance format here, but we've got an in toto statement with a SLSA provenance attestation. The subject is our binary that we generated. And we can see that we've got the SHA-256 digest of that binary. We have our predicate tells us that it was built with the builder that we specified. So this is the SLSA build level 3 generator. It was built from my repository, and that's the SHA-1 digest of the Git repository head. And there's a bunch of other information in there that's kind of specific to this GitHub builder. And so I'm now going to use the SLSA verifier tool, which is a sibling tool that can verify artifacts from a bunch of known builders. This tool is pre-configured to trust the SLSA generator in its build route. And I'm telling it I want to verify my artifact. I've got some provenance that I want to verify it against. And then I'm telling it I expect it to come from this builder, and I expect it to come from this source URI. And here's the artifact I want to verify. And why did that fail? Oh. Okay. So what did I do there? You can see that if I pass in my actual source URI, the verification passes. So what the verifier is doing here is first it is verifying the subject matches, it's verifying the signature on the attestation is valid, and then it's verifying the values that I passed. So it's verifying that it's from the expected builder, it's verifying that it's from the expected repository, and then it tells us that everything passed. And when it failed the first time, that's because I actually passed in this different source URI. So the GoToF project is from the CNCF project, the update framework, and this is the canonical upstream location. And if I try to verify it against the canonical upstream location, you can see that, yeah, the signature verifies, but hey, the provenance doesn't verify because this is fetching from a different location than, you know, the build has happened from a different source repository than I have passed to the tool here. And you can see that with this, we can start to build up our expectations and a model for defining and verifying policy. You could do this numerous ways. You could have, you know, your central package registry, know what the canonical source repository is and define expectations for a bunch of the content on that repository. Or you could detect kind of drift from good values. So the first time you verify something, you could see it comes from the update framework repository, and then a future binary. If the source URI has changed, that causes you to, the verification would fail, and it would give you an opportunity to investigate and potentially update your policy. So this is a powerful set of primitives to start building on. But yeah, we've now got a very simply, in a few minutes, we have been able to add SLSA support to a project on GitHub and generate and verify some provenance attestations.
Okay, great. So that was the demo, and that concludes the pre-prepared material.
SLSA
hand over to Omkar.
using the SLSA GitHub generator.
Sorry about that. Yeah, sorry. Let's head over to Omkar and move on to the Q&A portion.
Thanks so much, Josh. We heard your comments. As with all demos, something's got to go slightly askew. So we heard the volume may have been a little low. Our operations team has posted a YouTube link that y'all can utilize to listen to the demo offline. Hopefully those that turned up their volume weren't blown away when we came back at regular volume. So apologies for that. I'm going to have to follow up with Joshua about his use of Emacs, though. That seemed a little dodgy. I don't know about that, my friend. However, why don't we move over to the Q&A portion? So we had a couple of questions that were popped up in Zoom that I believe have been answered, and we also had a couple of others to get to. The first question was, when attestations are being generated, are they saved to logs? Can the logs then be verified? Michael stepped in and answered that it would be clearer in the demo, but an output of your build will be the signed JSON file with that information that is an additional output of the build. Michael, did you want to add anything in your response before we move on to the next?
Sure. Yeah, I think as Joshua kind of showed, right, it's you're almost like capturing information that you might anticipate capturing from a build log, and you're capturing all the important information into that SLSA attestation, with the really important pieces being, what was the output hash of whatever you built, what were the input hashes of the dependencies, what was the input, commit hash of the code, so you have all of that recorded. So once again, it's still based on trust, like you are trusting that the SLSA builder, is doing all the right things, but you could always, assuming that you do trust those parties, right? You trust GitHub, for example, with the GitHub Actions builders. If you trust those things, then yep, you can then go back, you can verify, and a lot of those things you could go back and verify, especially in the open source space, right? If it's a SLSA, if it's a open source thing, you can go back and say, hey, does this hash of this artifact actually reflect a hash in the source code? Do these things, all kind of correlate? Yeah.
Okay, wonderful. Thank you so much for elaborating on your answer, Michael. Next up, we had a question about, do we have a list of recommended build platforms and build processes, workflows, and frameworks? Marcella answered, this getting started page provides guidance on implementing SLSA as a developer, including a list of recommended build platforms. And there's a URL there, salsa.dev/get started, with an anchor of builder-salsa-levels. Marcella, did you want to elaborate on that answer any further?
Yeah, what I would probably add is that it's it's targeting developers, so individuals who, like Joshua's demo is showing, are trying to incorporate SLSA into their CI/CD workflows. There are also pages that are specific to organizations looking to implement SLSA, and essentially build platforms looking to SLSAify their infrastructure as well. So I posted the developer one, but the salsa.dev page has a lot more guidance around that.
Thanks so much, Marcella, for elaborating. Next question. Does SLSA support both Linux and Windows builds? Michael's answer was that SLSA is just a set of security practices. So anything that supports SLSA practices and attestation in production would support it. There's various tools in the space that support Linux and Windows. For example, Tecton, GitHub Actions, and various vendors. Michael, anything more to add there?
No, I think as Marcel also brought up, going to the getting started page, I think there's a lot of different tools that are out there. There's a lot of different, vendors like ActiveState and a lot of other folks who have a lot of different tools that support either Linux, either Windows, or in some cases both. And yeah, so and we believe that all those practices should be applicable regardless of operating system and also regardless of language ecosystem. So whether you're developing in Python, Go, Rust, building a container. We think those practices apply across the board.
Thanks so much. And sticking with you, Michael, for a minute, there was another question that you'd answered regarding, is there an ETA for the container builder and for building Docker images becoming available? Now, you'd answered that Tekton and a few other tools currently support container images with SLSA. And as far as a GitHub action under the SLSA community, you're not sure of when that might be. Anything further to add there?
Yeah, not sure, and maybe I don't know if Joshua knows if there's been any update on that, but there's been a lot of work to get stuff like the Go releaser, to get stuff like a build your own builder thing, NPM, and a bunch of other sorts of builders. And one of the things that is on the roadmap is a container build one, specifically from our community. If you go to Tekton, which is an open source tool, or a lot of the other tools that are out there, I believe Docker supports a build, was it BuildX or something like that, supports an earlier version of SLSA, but there's a bunch of other tools that support that. But Joshua, do you know if the GitHub action from our end is when that might happen?
I know the SLSA GitHub generator can generate provenance for container images, but doesn't do fully isolated builds for container images yet. So that is work in progress, but hasn't been completed and included in a release at this time.
Thank you. Sticking with Joshua for a moment, why did you choose to use an operating system as your text editor and using Emac? No, I'm joking. These are some questions that haven't been answered yet, so I'll just open it up to our panelists, free for all. There was a question that said, to my understanding, isolation is about build systems. How about air-gapped build systems where all source is stored locally? Who wants to take that?
I think I can start. So I think, when it comes to all of this stuff, it really depends on what your what is what you're considering your system. So in this case, you are still pulling stuff into that air-gapped environment. And so you want to have the provenance of what you pulled in. And assuming, let's say, you have also pulled in and you've sort of signed off and said, yep, everything we pulled into this air-gapped environment is great. Anything that is built in with that inside that environment, you still want to keep track of within that environment, because you don't want somebody, hey, a malicious actor within who has access to your air-gapped environment starts poking around, starts doing things. You still want to be able to sort that out, still be able to kind of track that and detect and remediate against it.
Sounds good. Any of our other panelists want to jump in on that one? All righty. Next question. When a process matures, do you expect the attestation signing to be done by a trusted workload versus an end user themselves? Who'd like to take that?
Yeah, I can take that. The attestation signing absolutely shouldn't be done by the end user themselves. We want the SLSA model is that the attestation is signed by the trusted control plane of the build platform. And the reason we want that to happen is because we want fewer opportunities for the values in the attestation to be tampered with, and for it to reflect as accurately as possible the work that the build platform has done. So in the SLSA GitHub generator case, the signing happens on GitHub using the machine identity of the GitHub action workflow to get a short-lived certificate from a Sigstore project and sign with that. So you can, the signing event is bound to that specific run of the workflow on the GitHub's infrastructure. And that's kind of it doesn't have to be Sigstore, of course. Build platforms likely have access to KMS systems and things, but ultimately you want a key that's accessible only by the control plane to be signing the generated provenance, and as few users involved as possible.
That makes sense. Anyone else want to jump in on that answer?
Yeah, I might add that the problem of delegating, right, trust and authority from organizations to individuals is pretty hard. And so the current solution that that Joshua was talking about, I think, gets around that by, yes, delegating, or still giving that authority to individuals. So just giving some extra background as to why it's not quite so simple to just have a single organization sign on behalf of folks.
Thanks, Marcella. That makes sense. Maybe sticking with the idea of signing and cryptography a bit, self-professed crypto nerd here. Curious about your thoughts on how important HSMs or hardware security modules are for protecting keys that perform these signing operations. Any signing operations, and forgive me, I'm going to rephrase this slightly. Are there any signing operations that are more critical than others? Again, for the panel.
So yeah, no, I definitely think, you know, when it comes to a lot of this stuff, there is, you know, at the end of the day, it's only as good as you know, the signing of the stuff is only as good as, you know, protecting the identity. So hey, if you know, if you're using a key, the more secure that key can be. And in fact, actually, I'm going to hand it over to Marcella, who is actually working on some stuff in that space for the future.
Yeah, not with HSM specifically or hardware security modules. Yeah, totally agreed with Michael that yeah, the signing operation is only as safe as the keys doing the signing. There's some work around that I've been looking at around using kind of secure enclaves, hardware enclaves, trusted execution environments for doing some of these sensitive operations because of their runtime kind of integrity properties that they provide. And so that might be kind of a potential alternative to using HSMs. See that.
Thank you so much for that answer, Marcella. It looks like we're just about out of time. To my esteemed panelists, thank you so much. Any calls to action for the community? What would you like them to do, my panelist friends?
Come join the community meetings.
Come join us. Sorry, go ahead, Josh.
So yeah, I was just going to say, join it. Like we use Slack and GitHub, and we have regular meetings, and we really welcome diverse inputs and ideas to help strengthen these things and develop new tracks in future. So definitely encourage you to come and join us.
I also talked about the 3 different levels of SLSA, and I know the committee is also looking into SLSA level 4, and that's something that's still being defined. And you know, you should definitely encourage you to join the committee and listen in and provide your input on helping to define SLSA level 4.
Thanks, everyone. Jennifer Bly from our team has put a bunch of links in the chat, including a quick survey about this tech talk. We'd love to get your feedback as to whether tech talks like this are valuable. As my colleagues have said, this is an opportunity for everybody to get involved. We recognize at the OpenSSF that the security of open source software is a joint accountability between the public sector, private sector, and community. So we'd love your support. Look forward to seeing y'all again soon. Thanks to everybody for joining, and let's try and find ways to incorporate SLSA into our build processes. Thank you, everyone.